Hi, good morning all, and thanks for being here so early. I hope that you are not as jet-lagged as me, just because that would mean that you'd be a little bit with a terrible headache. So my name is Daniel Mellado, and I've been the PTL for Kuryr-Kubernetes since 2 cycles. So I just wanted to give you a brief highlight of a couple of things that we have been working into this cycle, and then I'll show you a small quick demo. So first of all, that's the agenda. I'll be starting introducing what Kuryr and Kuryr-Kubernetes is for those of you who don't know about the project. Then I'll speak about what did we do in Stein, and then a little bit about sneak peek about the future work. By the way, once that we are done with the presentation, it'll be available there in my GitHub pages, so feel free to check it out. Okay, so what's Kuryr? So this is our nice mascot, which is a platypus. Prior to that, we used to have this guy. Well, this was something that the previous PTL, Tony, did. It's just a Kuryr because Kuryr stands for Kuryr, actually, in Czech, because he was living there. And basically, we exchanged messages in between Kubernetes and OpenStack. So we have quite a few projects. We have mainly 2 in active development. The first one is Kuryr-Kubernetes. It's basically, it's made of 2 components. The first one is a CM plugin that it's using Neutron to provide networking for Kubernetes pods, and also a controller which provides Kubernetes services using Octavia or Neutron LVAS version 2. This was truth until Stein. Here in Stein, we are completely removing any support for LVAS version 2. So ongoing, you will have to use Octavia if you want to use Kubernetes services directly. Second thing, we are also having a Tempest plugin where we integrated Kubernetes Python client with Tempest, so you could do some testing such as create a service, create a pod, and check connectivity. We also have 2 projects in maintenance mode, which is Kuryr and Kuryr Live Network. Basically, Kuryr, which we are showing called Kuryr Live, it's a library that we use to provide Docker networking plugin, and Kuryr Live Network is just a Live Network plugin. So this is basically maintenance mode, and besides the stable branch, it doesn't get updated too heavily at all. And here in Stein, we removed Fuxi. For those of us that you don't know Fuxi, it was a little bit of trial to replicate what Kuryr-Kubernetes does, but using CSI instead of CNI. So what did we work here in the Stein cycle? So first of all, now we are not supporting running Kubernetes without the usage of a daemon. For those of you who were attending yesterday's presentation from some guys that were using Kuryr-Kubernetes, they were using this without daemon, so their slides are now a little bit outdated, but I'll be covering that later on another session on the project onboarding. So we are now removed, as I said before, load balancer version 2. Also, I can probably announce that we have released in this cycle of Stein our first stable version, which is 1.0, so congrats on all contributors. And I just wanted to highlight a little bit here that if you see in this matrix, we are corresponding if our Kuryr-Kubernetes version with Kubernetes and OpenShift version. So basically, and even if it's not stated here, we would be also supporting OpenShift 4.0 with this latest version. So one of the main topics that we have been working into Stein was the network policy support. For those of you who don't know what network policies are, it's the way that Kubernetes allows you to restrict or apply policies in terms of communication in between pods. With the usage of Kuryr-Kubernetes, you can take that and also apply those to communication in between VMs and pods, which I think is kind of cool. So how are we implementing this? We are also using a heavy usage of CRDs, which stands for Custom Resource Definition in Kubernetes, just in case you are not familiar with the term. So what we did do was create a new one for our usage, which is called Kuryr Net Policy. This is basically, well, this is just a network policy, just the usual one. So we are putting all this into our spec alongside some stuff that we do. We have added a new handler and to handle these network policies events, and we create one CRD per network policy event in Kubernetes. So if you see here, basically, we get Kubernetes here on the very left. And so whenever we receive one network policy event, we handle that. And by we handle, it's the handler who is doing that, and we parse it. And we are speaking with OpenStack, so we are creating one security group and several security group rules per network policy from Kubernetes. And afterwards, once that we have been doing the creating operation, we are no longer relying on Neutron because it would take so much time to talk to Neutron every time that we are creating a network policy. And instead, we are creating a CRD, and we are annotating all the Neutron IDs alongside. You'll be seeing that later on the demos, no worries. So yes, that's basically it. So this is a much faster way to get a speed on this, because we were doing some performance testing, and we can get up 5 per faster speeds, avoiding talking to Neutron. So I guess that's a good thing. Also, another thing that we were working with the network policies was, I don't know if you were familiar with the isolation that we were working. Basically, we were relying on namespaces, and now we support both namespaces and network policies. Because using network policies, you have, it's some kind of enhancement from what we were doing before, because now you have a much more granularity if you want to tackle that. So if you are not using network policies, whenever a pod is created, we create security groups on demand just to ensure that isolation. But if using network policies, you would have this, and on top of that, you would be gaining all these. You can do whatever you want in terms of rules. Also, Cryo. So what is Cryo? Basically, it's another runtime for containers that we were just using instead of using Docker daemon. So one of the good things that we were thinking about using Cryo instead of Docker is that it's much more lightweight, and you can run it without leveraging on the heavy usage of the Docker daemon, which no longer needs to get there. So CRI, Cryo, it stands for Container Runtime Interface, since 2018, it has been an official part of Kubernetes family of tools. It's an open source project. A lot of contributors to Cryo also contribute to Kubernetes, such as Red Hat, Intel, SUSE, quite a lot. So one of the things that we did like really is in terms of security, because in Docker, every container is a child of the large Docker daemon, but Cryo container are childs only of the process that is spawned it, and that could be just only done by a user. Also, thanks to the Samsung guys, one of the things that we think it has been really important in this cycle is SRIOV support. There's a plan to enhance this farther away alongside Intel Multis. So one of the features that we would love to have for the next cycle is to have several interfaces in one pod, and having SRIOV take one of those to handle offloading to faster hardware or faster NICs. But so far, SRIOV is working with their patches. This is just somehow not fully integrated in time, but this will be done in the next release. Things for the future, as I was saying, mainly we are done with Python 3.6 and 3.7 support. We also want to enhance UDP services, SRIOV support. Network policy support is done. We just need a few more testing. And with SRIOV, we need to tackle with Samsung, because we would need some third-party CI from their side, because as of now, the OpenStack infrastructure doesn't support SRIOV in their upstream CI. So there's no way that we could test this upstream without a different specific hardware. Also in progress are DPDK support alongside SRIOV and Multus. So if you want to contribute, feel free to hook it out here. We are on an IRC. And with this, I think I'll be trying to go for the demo, and afterwards we'll be doing some Q&A. So let me know if you could see this. It's OK, or do I make it bigger? OK. Okay, so this is just a common network policy. This is being taken from the examples on Kubernetes, just in case you want to take along. Basically, it allows you to speak to some ports, TCP and ingress and TCP egress. Here we have an AP block, which is basically a way that network policies have to restrict to a specific CIDR. It has an accept, and it has some selectors. I won't be going over this unless you have several questions later. But if you have, please feel free to ping me offline or afterwards. So we are going to create this network policy. Let's see if Kubernetes got it. OK, cool. So now Kuryr would have been created under the hood once CRD in response to this. We have here done this short name, KNP, stands for Kubernetes policies. OK, here it is. Let's go take a look at it. You see we have here on the spec basically that. So let's see what OpenStack did under the hood. So this is the security group that was done in OpenStack, and we'll see what kind of rules did Kuryr create under the hood. OK, so you see there we have quite a few. Basically, you could have a question about why do we have so many? It's because when we are using IP block and accept, we are creating, let's imagine that we have an IP block, which is a CIDR of /16, but we want to subtract a /24. That would give you like 15 /24. So that's why we have so many. Each of those corresponds to one of such CIDR. Now we'll be creating a deployment to check if this actually works. OK. Let's wait for the pods to be up and running. So here's the pod, and Kuryr-Kubernetes already set up its IP there. You can see 10.0.0.202. So this is a pod that we have for testing purposes, which is basically a small web server that would reply to the port 8080. As of now, we haven't gotten any rule for port 8080, so no communication will be established. See, it won't work. So let's go and open the 80 port. 80, let's modify the network policy. So it would modify the Kuryr policy under the hood, and it would modify those neutron security groups. So this feels long and scary, but this is just updating the network policy. So now we have around the 8080 ports too. And now we call it. And of course, it failed because of the live demo, but I promise you that this works. OK. Yeah, it just took a little bit. Because we are doing a lot of security groups under the hood. So, and there's also this server. It's based in Europe, so the latency isn't the best. But it works. So as I told you before, that's just a web server that tells that, hello, I'm alive. And actually, if you want to contribute, you'll be seeing it quite a lot on the testing. So, but I was speaking about Cryo before. We haven't gotten any. So that's why I think it's important to check that the Docker daemon isn't running at all. But now, I don't know if you are familiar with Podman and Builder, but those are two projects. Podman, basically, it's a CLI tool that would allow you to interact with Cryo in the same way that you are using Docker. So as you can see, like Docker's not responding because there's no Docker daemon. But if we go and we get to Podman, we'll see that those are basically the Kuryr-Kubernetes containers that we have under the hood. So, questions, guys? Go ahead.
Thanks for the update. The policy, is that supported across multiple Kubernetes clusters?
Sorry, I don't know if there's a mic available because. Or
So the network policy support, is there support for multiple Kubernetes clusters and multiple stacks?
alongside, no, not as of now. So far, we only support one Kubernetes cluster, but going across several clusters, that's something that we would like to cover in the next cycle.
Cheers, thank you.
So if there's no more questions, thanks for attending. Oh, yeah, sure. Go ahead.
Yeah, you missed out on the beginning of your presentation, so apologies if you explained that already, but could you use the same mechanism to create tenant networks with Neutron?
Well, basically, it's not that we are creating the networks per se. The tenant networks would be created by Neutron, but you could just go and add the driver for that. I mean, when you are doing the Kuryr-Kubernetes configuration, you would have to go and specify a network for either for the pods, or if you are using the network isolation mode, which I explained on namespaces and network policies, those would be created for you under the hood. So we are not covering. You don't need to go for a tenant network because that would be just given you for free. In any case, if you want to specify one tenant network, that would be a new feature. So feel free to propose it.
So would it be possible to have a separate tenant network for each project that covers it?
Yeah.
Fantastic, thank you.
So go ahead.
Could you flash up your GitHub address again? You said the presentation.
Your table? Yeah. This one, you mean?
No, you said the whole presentation was about your GitHub. Can you flash up your GitHub address again?
You mean here?
Can you switch the tab on?
Yeah.
Oh, sorry. Yeah. I was saying it, but you weren't. So hold a second. So we still have like 2 minutes, and if you have any questions, feel free to ask. And otherwise, I would use a coffee, guys. So thanks for attending.